Okay, so for question 1, it's asking us which representations are functions. So let's just think about again what tells us when something is or is not a function. To be a function, every x has to have its own unique y. So the x's cannot repeat with more than one y value. So if I look at the table, I'm looking at all my x values, and I notice that this positive 2x value is associating with a positive 6 and a negative 6. So that is not a function. Go over to relation 2, which is giving me a set of ordered pairs. So I'm looking at all my x values, and I see that every single x value here, I have a 1, a 2, a 3, a 4, a 5, a 6, and a 7. Nothing repeats, so this is a function. Go over to 3, which is a graph. When I look at graphs, I'm going to use the vertical line test, and because this vertical line does cross this graph at more than one place, that means that that x value is repeating with more than one y. So that would not be a function. And choice 4 here, this is the equation that hopefully at this point we recognize. It is a linear function, y equals mx plus b. So you could type this into your calculator, or just think about the fact that this would have a y-intercept of 1, and it has a slope of 2, so up 2 over 1, if I just wanted to give myself a little sketch here. And that linear function, again, would pass the vertical line test, so that is also a function. So I am looking at 2 and 4 as my functions, so choice 2 was my answer. Okay, for question 2, they're asking us to evaluate this function f of x when x is equal to 1/2. So remember, the value in the parenthesis is x, and right now they're telling me to plug in a 1/2 for x. So just algebraically, that would look something like this. But at this point, I would say, think about what you're doing. Think about what we're plugging in for x here, but then go to your calculator. Okay, so if I come into the calculator here, I would like to type in that fraction of 1/2 and store it for x. So alpha y equals enter, 1 over 2. Store button is right above on, storing it for x, hitting enter. Now I'm going to type in that entire function. So again, that function happens to be in fraction form, so I'm going to open up a fraction. Then I need a square root, so that's going to be second x squared. I'm going to type in 2x plus 3, scroll down, and then type in 6x minus 5. So I've stored the 1/2, that's my input, and when I hit enter here, that would be my output of -1. Okay, question 3. Use the given information to find the slope. So if I'm finding the slope, formula for that is change in y over change in x, which takes my y2, my second y value, subtract my first y value, and then in the denominator, same thing, but with x, x2 minus x1. So I need to identify what they're really giving me here. F of 2 equaling 5. Well, remember, the number inside is x, and what it's equal to is y. So this is really like giving me the point 2, 5. Same thing here. 6 is going to be my x. 5 is going to be my y. So here's the point 6, 5. I go to find the slope here. If I label this first point x1, y1, and this second point x2, y2, this slope formula, if I plug in, I would have 5 minus 5 over 6 minus 2, which is going to give me 0 over 4. Anything dividing into 0 is going to be 0, so I have a 0 slope. Choice 1. Okay, number 4. Which statement describes the graph of x equaling 3? So let's think about this on a grid. Here's my x-axis. Here's my y-axis. Okay, so x equaling 3, that would be over here, 3 units. Now I want to think about, well, where would x continue to be 3? I know it's 3 here. If I go left or right, I would be changing my x. But if I go up and down, my x should still be 3. So if I went up vertically or down vertically, I would end up with this line of x equaling 3. Let's see, 3. There we go. So x equals 3 everywhere on this vertical line. So now I have to look at my choices. It has a slope of 3. Well, that's not true because the slope of 3 would be going up 3 over 1, and that is not happening here. That would be slanted. It is parallel to the x-axis. Well, that's also not true because here is my x-axis. It is not parallel to it. It's actually perpendicular to it, so that would not be correct. It is parallel to the y-axis. Well, yes, I do agree with that. So this is definitely a correct choice. And then it passes through the point 0, 3. Well, no, that can't be true. 0, 3 means y is 3, and that would be this point over here. So it has to be choice. Paula was given the equation y equals negative x plus 3. Which of the following is equivalent of an equivalent representation of this equation if we put it into function notation? So the biggest thing here was just remembering that y can always be written as f of x if we know it is a function. So if I replace y with f of x, my equation could also be written like this, which is choice 4. Okay, each month, Jesse's phone bill includes a $25 basic fee plus a charge of 7 cents per minute for the number of minutes of long-distance calls that she's making. They want us to find the equation that best describes the total amount of Jesse's monthly phone bill. So total amount of the phone bill is what the equation's representing, using T and M, and the number of minutes is the long-distance calls, that's our M, and the total amount is our T. So really, T is being represented in terms like this would normally be my Y, and M would normally be my X. These are my inputs and my outputs. So if 0.07, that's 7 cents, is per minute, and M is being represented as the number of minutes, I'm going to need to multiply the 7 cents with M. $25 being my basic fee is my y-intercept. That's the amount that I have to pay no matter what. That's the constant. And they're telling me if I take this together each month, that would give me my total cost, that sum. So this gives me choice 2. Remember, the additive property, the commutative property of addition does allow me to rewrite this, which is why choice 2 is correct. I can always rearrange my terms and still be equivalent. Okay, question 7. Jamie is having a party. This group rate is described by this equation. We have C equaling 3n plus 20. C is our total cost. That's my output. That's my Y. N is the number of people at the party. So which table would correctly show the cost in dollars if the party was 10 people big, or 20 people at my party, or I have 30 people at my party? So these are all different n values, since n is representing the number of people at my party. So if I plugged in 10 for n, what would I get? Okay, well the cost would be 3 times 10, which is 30. 30 plus 20 would give me a cost of 50. If I plugged in 20 to that equation, what would I get? Well, 3 times 20 is 60. 60 plus 20 is going to give me 80. It's going to cost me $80 if 20 people come. And if I look at 30 people at my party, 3 times 30 would give me 90, and 90 plus 20 would give me 110 for my cost. So now I'm just looking for a table that has these associations. So 10 needs to be associated with 50. I only see that happening in table 3. So really just finding the first input and output would have helped me. But then let's just double check. 20 is associated with 80 and 30 is associated with 110. So choice 3 is my answer. Okay, for question 8, which point lies on the line defined by 3x plus 6y is equal to 2? So for something like this, you would just take your values in these points, remembering that each value is x comma y in the point, and plugging them in. The one that makes it true is going to be my solution. It's going to be a point on this equation, on this line. So let's take an x value of 1. Let's start with our first choice, plus 6 times y, which in this case is negative 1/6. And we're basically asking ourselves, does this equal 2? Because we're not sure until we start to simplify on the left. So 3 plus, well, 6 times negative 1/6 is going to give me a negative 1. 3 plus negative 1, or 3 minus 1, is going to give me 2. So I got lucky that my first choice ended up being the solution. If it did not work out, I would have continued on and checked each point until I found the point that made the equation true. Question 9 is talking about a student writing a composition for homework. They're keeping track of the number of sentences compared to the time. So how many sentences they're writing in comparison to the time it's taking them to write them. They give us a graph to show the data. They're asking us what the rate of change is that Ryan is writing his composition. Rate of change, again, just means slope. So we're being asked, what is the slope of this line? Well, let's take a look. Here's a point 0, 0, and here's a point that I can see based on my intervals of 20, 30. So I went up 30, and I went over 20. So change in y over change in x would be a simplified fraction of 3 over 2, or a decimal of 1.5. So the rate was 1.5 sentences per minute. Question 10. To which of the following situations can this function y equaling 5x plus 10 be applied? So let's take a look at each one. Okay, so for answer choice 1, it says the number of miles a person is walking if they walk for 5 hours at a rate of 10 miles per hour. So that would mean that my slope here is 10. And what they're actually giving me in choice 1 is not really a function. Well, first, we already have 10x, so we know it can't be this answer. But what they're really giving me here is 5 hours at this rate. So they're almost just telling me, all right, plug in 5, so you went 50 miles. But again, not matching up with our equation. The total weight on a scale, if 5 pounds is placed there initially, again, hint, the word initially, that usually corresponds or will correspond to our initial value, which is our y-intercept. We're looking for it to be 10. In this case, it would be 5, and they're telling me 10-pound weights are added to it. So again, the initial value is supposed to be 10. In this case, it would have been 5. Does not match up. Total wages earned by a waiter who is paid $5 per hour, so that's good for my rate, and earns $10 in tips. So that's going to be the amount that they earn no matter what amount of hours they work. So that would be their starting value or initial value. So choice 3 matches up with my equation. Okay, question 11. Is this equation equivalent to the other equation? So is 3 times 2x minus 4 equal to negative 18, equivalent to 6x minus 12 equaling negative 18? The first thing I would do here is, this is definitely the left equation, is showing me that 3 can be distributed to that 2x and minus 4. So I'm going to distribute it and see what I get. 3 times 2x would give me 6x. 3 times negative 4 would give me negative 12, and that would still be equal to that negative 18. All I did was use the distributive property. Now I can see that these two are equal, so I would get rid of the choice that says no. They definitely are equal equations, but why? Are they equal because of the associative property of multiplication? Well, no, we didn't reassociate anything here with our parentheses. So yes, they're equal equations, but not for that reason. Yes, they're equivalent because of the commutative property. Well, no, we didn't change the order anywhere, but yes, they're equivalent. But choice 3 is my answer because they are equivalent due to the distributive property of multiplication over addition. Okay, question 12. Which equation is represented by the graph shown below? So I'm really being asked here to write the equation of this line. So I'm going to first identify my y-intercept, which is negative 1, 2, 3, 4, negative 5. And then I'm going to identify my slope. So I'm going to find another nice point here, and it looks like I'm going down 2, right 1. So down 2 means negative 2 over 1, so my slope is negative 2. If I were to write this as an equation in y equals mx plus b form, I would get negative 2x minus 5. Now I look at my choices. Choice 2 is really tempting. However, the equal sign is not in the right place to match up with my equation. If I solve for y here, I would have to start by adding over the 2x. So this equation is very similar. It has the same y-intercept, but it has a positive 2 slope. So that would not be correct. If I went back to equation choice 1, I would start by subtracting the x to both sides, so I would get 2y is equal to negative x plus 10. Divide by 2, and I can already see this is incorrect, because now I have a slope here that's fractional. It's going to be negative 1/2 x plus 5. So the y-intercept is wrong and the slope is wrong. So moving on. Choice 3, I'm going to divide everything by negative 2. So I get y is equal to negative 5x minus 2. So notice there, they're trying to confuse you a bit, or not confuse you, but try to throw you off of what should be your y-intercept and what should be your slope. So negative 2 and negative 5 are important numbers, but not in this order. And if I look at choice 4, I get y is equal to negative 2x minus 5. That matches up with what I initially got when I wrote my line, and now I can choose choice 4 as my answer. And the last multiple choice question here, we're talking about a girl and her cousin going to a restaurant. The girl's dinner costs her $5 more than her cousin's. Okay, so that means her cousin's dinner, we don't really know what it is, so we'll call it X. And Gemma's dinner costs $5 more, so that would be X plus 5. They tell me if their combined bill, so if I took their two amounts for dinner and added them up, was under $25, which means it's less than 25. Now I'm going to look at my choices, and I do match up with choice 2. However, if I had put parentheses here, as long as there's just a plus sign in front of those parentheses, it's not going to change the equivalency of this inequality. So my inequality and the one in choice 2 are the same. Okay, so for number 14, they wanted us to draw the equation y equals negative 2x plus 4. So the first thing you want to do is identify your slope and your y-intercept. So your slope is always the number that is right in front of your x. So my slope, or my n, is negative 2. And my y-intercept, or sometimes we call it our b, is, again, recall the equation of a line, is y equals mx plus b. So if we want to graph this, we're going to start our y-intercept of 4. I start my origin, go up 1, 2, 3, 4. That's going to be my first point. And then remember, we have a negative slope, so if you want, just draw a little sketch so that you know that it is going to be a line that is decreasing. And we're going to go down 2 and over 1. And we're going to continue that pattern. Down 2, over 1, down 2, over 1. If we wanted to continue in the other way, we would go up 2 and then to the left. Now, once I have a few points, I could grab a line and I could connect them with my line. Again, we want to just make sure that we add arrows to both ends of our line, and then just finally just write the equation. So y equals negative 2x plus 4. The second point, they want us to identify if the point 3, negative 4 is a solution to our equation. Explain your answer based on the graph that you drew. So if we look, the point 3, 1, 2, 3, negative 4, 1, 2, 3, 4, it's actually here, and that point 3, negative 4 is not on our line. So that means that that is not a solution to this equation. So you're going to say no. 3, negative 4 is not a solution. To the equation. Because it is not a point on the line. And if you wanted to, you could have taken that point also and substituted it into your equation to see if it was a point. So you could have checked y equals negative 2x plus 4. Your point is 3, negative 4. So for y, we're going to put a negative 4. And for x, we're going to put a 3. And again, we're going to test to see if this is true. We would keep our negative 4 here. And if we do a negative 2 times 3, that's going to give us a negative 6. Plus 4, that's going to give us a negative 2. So no, that is not a solution. For number 15, they want us to write an equation of a line that passes through the points 4, 7, and 5, 8. So again, our slope formula is our change of y over our change of x. You could also write it as y2 minus y1.
over x2 minus x1. So if we take our first y point, which is 8, minus 7, and we're going to divide that by our x value. So we picked 8 first, so we need to pick the point, the x value that's associated with our 8, which is our 5, and then minus our 4. And we would get our slope of 1 over 1, which is also just equal to 1. Now, we want to write the entire equation of the line. So we know we're going to need something that looks like y equals mx plus b. All we've done so far is find our slope, our m value. So we need to find that b value. In order to find our b value, we're going to take either point and substitute it in. So I'm going to take this point for 7. So for y, I'm just going to rewrite this, y equals mx plus b. For y, I'm going to substitute in my point 7. My slope, my m, I found is 1. For x, I'm going to plug in that value of 4. And then I want to solve for my b value. So if I just move this up a little bit, 1 times 4 is just 4 plus b is 7. Again, I'm going to subtract this 4 over to get my b value of 3. Now that I've got my b value, I just need to put it all together to write the actual equation. So I'm going to have y equals, my slope was 1, so you can write a 1 there. Or you could just have an x plus my b value or my y-intercept is 3. So this is our final equation that does go through those. Okay, so for number 16, there's actually 2 ways that we could do this. So I'm going to show you both. If we have this minus 1/3, I can add my 1/3 to both sides. When I add that, I'm going to have still my x minus 2 over 4, and that's going to equal 8 over 3. Again, when you have fractions, you can do them right in your calculator to make sure that you get the correct number. So here, now what we're going to want to do is cross multiply both sides. When we write this, make sure you put your 3 in parentheses, x minus 2, and that's going to equal 32. Okay, so now that we have this 3 on the outside, we do have to make sure that we distribute this in. So we're going to have 3x minus 6 equals 32. Then we want to get x by itself, so we're going to add 6 to both sides. Once I add 6 to both sides, I'm going to have 3x equals 38. Now, my final step, I'm going to divide by 3 on both sides. And when you write your value of x, you could just write and leave it as this fraction, 38 over 3. And that is your solution of x. Now, there's another way you could do this question, which I'm going to do now over here. You could have done the LCD method. Okay, so if I wanted to take the LCD approach, I'm going to look at the numbers that I have in denominators, which are 4 and 3. And my LCD between those two would be 12. So what I want to do is I want to multiply each term by 12. Now, you want to see if you can reduce anything. So how many times does 12 go into 4? That would be 3 times. How many times does 12 go into 3? That would be 4 times. And 12 goes into 3 again 4 times. Now, you need to make sure that when you reduce these, you remember to multiply them in. So we had our 3, and this is an entire term, so you need to remember to multiply by that entire term. So 3 times x minus 2. Minus 4 times 1 is going to give us our 4. And then with that 4 times 7 is going to give us 28. So equals 28. Now, in order to solve this, we want to start with distributing this. So we have 3x minus 6 minus 4 equals 28. We can combine our like terms here. So 3x minus 10 equals 28. Add your 10 over to both sides, and you're going to get 3x equals 38. Final step, divide by 3 on both sides, and again, we get our value of x equals 38 divided by 3. So either method that you chose to solve this equation, you should have gotten the same exact solution. So I do just want to mention, I went along and put this into my calculator. I did 38 divided by 3. And your calculator is going to give you a value of 12.6 repeating. Now, what your calculator does is it takes that value and just rounds it because it can't fit all of the digits because it is a repeating decimal, so it's going on forever. So, if you did put this into your calculator and you wanted to write it as this answer, you would need to write it as 12.6 repeating. The question did not ask us to round, so you cannot just round this to 12.7. That would be an incorrect answer because they did not ask us to round it. So you either had to write it as 12.6 repeating, or just leave it as your 38 over 3. So number 17 was a literal equation. They wanted you to solve for A in terms of S, U, and T. So the first thing I'm going to do is I'm actually going to highlight A. This is what they want me to get by itself. So if I go back here, I want to get A by itself. Remember, when we solve equations, we're doing PEMDAS, but we're going backwards. So when we're evaluating an equation, we do parentheses, exponents, multiply, and divide, add, and subtract. But when we are solving equations, we do that in reverse order. So the first thing that we want to look for is addition and subtraction. So we see an addition sign here. If we look at this 1/2, because some of us might be tempted to subtract 1/2, we have to ask ourselves, how is that 1/2 attached to the A? Well, since they're just right next to each other, if you saw something like 1/2 X, you would know that that's multiplication between them. So we cannot just add over that 1/2 because that is attached to the A and the T squared by multiplication. So what we can subtract over, though, is this term UT. So if we subtract UT from this side and subtract UT from that side, can we actually subtract S minus UT? No, we can't. So we're going to leave that as S minus UT. And that's going to equal, we still have our 1/2 AT squared. Now, again, we have to look at this, and we want to now undo our multiplication and division. So the next thing I see is this 1/2 that we kind of want to get rid of and move that to the other side, so that again we can get this value of A by itself. So what I'm going to do is I'm going to, in order to undo that, we can either divide by 1/2, or we know that we can multiply by the reciprocal, which is 2 over 1, or just 2. So if I multiply by 2 on one side, I want to multiply by 2 on the other side. And remember, this is all one term. So I'm going to write this as 2 times S minus UT. Then these are going to cancel out, so I have AT squared. Now, I have this exponent here, but my exponent of 2 is only attached to my t. Only t is being squared. If I looked at my a, really my a only has a power of 1. Whenever we don't see something there, we just assume that it is to the first power. So if I want to undo these, how is my a and t being related right now? There is multiplication going on. So to undo multiplication, we want to divide. Now we're trying to get a by itself, so I'm going to divide by a t squared. And what I do on one side, I need to do on the other side. So I'm going to divide by a t squared. This t squared and this t squared is going to cancel out. And on top, I'm going to have 2s minus ut all over t squared, and that's going to equal a. So if we look again, they wanted us to solve for a in terms of s, u, and t. Another way that you could have written this is you could have, if you wanted to, distribute this 2 into the s and the ut. So you could have had 2s minus 2ut all over t squared, and that would also be an equivalent equation for what your value of a would be. Number 18 is telling us that a taxi charges $1.75 flat rate, in addition to a 65 cents per mile. Katie has no more than $10 to spend on a ride. Write an inequality that represents Katie's situation. Then they want you to use this inequality to determine how many whole miles she could travel without exceeding her limit. So the first thing that we need to do is write an inequality. So if we have a flat rate of $1.75, that's like our y-intercept, our initial case. So we're always going to be paying that $1.75. And then they're telling us it's 65 cents per mile. So every mile that we travel, we're going to get charged another 65 cents. So that's going to be 0.65. We add them together, and they said she has no more than $10 to spend. So if we have $10, we want no more than $10, so it needs to be less than, but we can equal $10. So that is our inequality that actually represents this situation. They then wanted us to use this to see how many miles she can actually travel. So if we solve this equation now, we're going to subtract $1.75 on both sides. 65x. We're going to keep our inequality symbol, and we have 8.5. Now we want to divide by our 0.65, divide by your 0.65. And you would have gotten an answer if you did it in your calculator. X is less than or equal to 12.69230769. Now again, if you put this into your calculator, you would have gotten this higher value on our calculator. At this point, they did not ask us to round, so we cannot just round our answer right now and say that it is 12.69. We can't round it to any value other than writing them all out, or you could have written a few digits and just put those dots to indicate that you know that that number is going up. Now, what we could do is they want to know how far she could travel without exceeding her limit. So if we graph this, we would have 12.69 dot. We can be equal to that, or we are any values less than that. So what whole number miles can she travel? Well, our next integer would be 12. So Kate can travel 12 miles. Kate can travel 12 miles, which is your final answer. So for our final question, they're telling us that a water tank is being filled by pumps at a constant rate. The volume of the water is represented by V and in gallons, and it's giving us this equation. So V of T, or volume of our tank, is going to be 65T plus 280, where T is the time in minutes the pump has been on. So at what rate in gallons per minute is the water being pumped into the tank? So rate, remember our rate is our slope. So what is our slope here? That is 65. It is a number that is right next to our T. So our rate is 65 gallons per minute if you would like to write that. The second part of the question is how many gallons of water were in the tank when the pumps were turned on? Turned on is another way of saying our starting value, our initial value, our starting point. So our B, our y-intercept, our starting point is this 280. So how many gallons were in the tank when it was turned on? 280 gallons were in there. The third part says, what is the volume in the tank after 2 hours of the pump running? Well, the first thing that we needed to see is that 2 hours is what our question is asking us. But overall, this function is in minutes. Our time is being represented in minutes. So we have to figure out how many minutes are 2 hours. So 2 hours, there's 60 minutes in every hour. So 2 hours would be 120 minutes. That's the first thing you would have to do. Now, I'm going to make us like a little chart to help us see what our x and our y values are. So we're talking about time, which is our minutes, and that is being represented by our x. So t, or time, is our input, which is our x values. So I'm just going to draw this little thing. T is really our x values, which is our input, what we're going to plug into our function. And then volume is what our function actually actually is telling us, our volume is our output, or our y, what our function is giving us, the amount of gallons that are there, our actual volume. So what is the volume in the tank after 2 hours this pump? Right. So time, 2 hours, is actually our x value, or our input. So when we go to solve this, we want to put our 120 as our input to our function. So v of 120, plugging in that, is going to be 65, raise this so that I have root 65 times that 120 plus 280. Now this part is just our function notation. We don't actually have to solve anything there. This is just telling me that I am plugging in my input of 120 to see what the volume is going to be. So what we do actually have to solve is this right side of our equation. So 65 times 120 is 7,800. And then I'm going to add that 280. If I add that, I'm going to get 8,080. So after 2 hours, or 120 minutes, there are 8,080 gallons in our tank. The last part is saying the pump will turn off when the volume in the tank hits 10,000 gallons. So the nearest minute, after how long does this happen? So 10,000 gallons, they're telling us that's our volume. So again, if we look at our chart, our volume is our y value, or our output. So if we look back at our equation, our output is represented by this v of t. So when we set up this equation, we're going to put our 10,000 where v of t is, because that's now our output, and then set that equal to what our function actually is, so 65t plus 280. So I just need to solve this now. When I solve this, I'm going to subtract 280, subtract 280. 65t is equal to 9,720. Divide by your 65. Divide by 65. And if you do that in your calculator, you're going to get a value of t is equal to 149.53, and so on. So if we go back to our question, we see that they asked us to the nearest minute. So if we wanted to estimate this to the nearest minute, at 149 minutes, it's not quite going to be at the volume of 10,000. So in this case, we're going to have to round and say that our time is 150